everyone, welcome to my channel. In today's video, we study about some important question paper problems on Maclaurin's expansion of series. Here is the first problem. Obtain Maclaurin's expansion of log of 1 plus x up to 4 decimal places. We already discussed in a previous video. Maclaurin's expansion at x is equal to 0 is given by f of x, which is equal to f of 0 plus x by 1 factorial into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus x cube by 3 factorial into f triple dash of 0 plus and so on, x power n by n factorial into f power n of 0 plus and so on. The equation continues. This is a Maclaurin's expansion at x is equal to 0. This Maclaurin's expansion is a special case of Taylor series where each of the successive derivatives is evaluated at x is equal to 0. Here f dash, f double dash, f triple dash, all these are successive derivatives which are evaluated at the point x is equal to 0. This is a Maclaurin's expansion of series. In the given problem, we are supposed to find Maclaurin's expansion of log of 1 plus x up to 4 decimal places. Up to 4 decimal places means you have to find the successive derivatives up to 4th derivative. Take the function f of x is equal to log of 1 plus x. We have to find the 4th derivatives, that is f dash, f double dash, f triple dash and f power 4th derivative. For that, this is a function f of x is equal to log of 1 plus x. To find f dash of x first, differentiate f of x with respect to x, we get f dash of x which is equal to, here differentiation of log x, this is of the form log x, differentiation of log x is 1 by x, that is 1 by 1 plus x. In the place of x, here we have 1 plus x. Hence we get 1 by 1 plus x. This is our f dash of x. Again differentiate f dash of x, we get f double dash of x as differentiation of 1 by 1 plus x is, if we take 1 plus x to the numerator, that becomes 1 plus x whole power minus 1. This is of the form x power n. We know that differentiation of x power n is n into x power n minus 1. Hence we get minus 1 into x is 1 plus x whole power minus 1 is minus 2. That becomes minus 1 divided by 1 plus x whole square. This is f double dash of x. Similarly, differentiating f double dash of x, we get f triple dash of x as, here minus 1 is common as it is. Differentiation of 1 by 1 plus x, if we take 1 plus x whole square to the numerator, that becomes 1 plus x whole power minus 2. Hence, differentiation of x power n form, we get minus 2 into 1 plus x whole power minus 3. That becomes minus into minus plus 2 divided by 1 plus x whole cube. Similarly, we get f power 4th derivative of x as minus 6 divided by 1 plus x whole power 4. This is about f dash of x, f double dash, f triple dash and f 4th derivative of x. After finding all this, we have to find f dash of 0, f double dash of 0, f triple dash of 0 and f power 4th derivative of 0. Hence, we get at x is equal to 0, we have f of 0 as, substitute in the place of x as 0, we get log 1 plus 0, that is log 1. We know that log 1 value is 0. Similarly, we get f dash of 0 as, substitute here also 0, that is 1 by 1 plus 0 is 1. That is our f dash of 0. F double dash of 0 is minus 1 by 1 plus 0 whole square, that is minus 1 itself. Similarly, f triple dash of 0 is 2 by 1 plus 0 whole cube, that is 2. F power 4th derivative of 0 is equal to minus 6 divided by 1 plus 0 whole power 4, that is minus 6. After finding all these values, we have to substitute in the Maclaurin's expansion formula, that is f of x is nothing but log of 1 plus x, which is equal to, here f of 0 value is 0 plus x by 1 factorial as it is into f dash of 0 is, f dash of 0 value is 1 plus x square by 2 factorial into f double dash of 0 is minus 1 plus x cube by 3 factorial into f triple dash of 0 value is 2 plus x power 4 by 4 factorial into f power 4th derivative at 0 value is minus 6 plus and so on. Till here we have to substitute the values. Now simplifying the term, we get log of 1 plus x value as, here x by 1 factorial is x itself, x, here plus into minus minus, x square by 2 factorial value is 2 plus, here we have 3 factorial is nothing but 3 into 2, here 2 gets cancelled, remaining will be 3, hence we get x cube by 3 plus into minus minus, 4 factorial can be written as 4 into 3 into 2 into 1, hence we can cancel 6 and 6 here, we get the remaining is 4, hence we get x power 4 by 4 plus and so on. This series is a Maclaurin's expansion of log of 1 plus x. This completes the problem. here to obtain a Maclaurin's expansion of any function means you have to take the given formula first, substitute all the successive derivatives at x is equal to 0, and after finding all these values, substitute in the given formula, we get the required Maclaurin's expansion of that function. We shall move on to another problem. Find Maclaurin series for tan x up to the terms x power 4. Here also we have to find the successive derivatives up to x power 4 itself, that is fourth derivatives. We all know that Maclaurin series is given by the formula f of x is equal to f of 0 plus x by 1 factorial into f dash of 0 plus x square by 2 factorial into f double dash of 0 plus x cube by 3 factorial into f triple dash of 0 plus and so on x power n by n factorial into f power n of 0 plus and so on. The equation continues. This is a standard Maclaurin's expansion. Take the given function, that is f of x is equal to tan x. First step, we have to find f dash, f double dash, f triple dash and f power fourth derivative. For that, differentiate f of x with respect to x. We get f dash of x as differentiation of tan x is secant square x. Here next f double dash of x is differentiation of secant square x is, here this is of the form x power n. So differentiation of x power n is n into x power n minus 1. Hence we get 2 into secant x power n minus 1 is 2 minus 1 is 1. Into, again we have to differentiate secant x term, differentiation of secant square x is secant x into tan x. Hence we get f dash of x as 2 into secant x is secant square x into tan x. This is our f double dash of x. Next we have to find f triple dash of x, means here 2 is constant as it is. Here secant square x and tan x both are function, so we have to apply product rule over here. Take secant square x as first function and tan x as second function. We get first function into differentiation of tan x is secant square x plus second function, that is tan x, into differentiation of secant square x is same as this, that is 2 into secant x into tan x. Multiply 2 inside the bracket, we get 2 into secant power 4x plus, here tan x into tan x is tan square x, secant x into secant x is secant square x, here 2 into 2 is 4 plus 4 into secant square x into tan square x. This is f triple dash of x value. After next we have to find f power fourth derivative of x value. For that, here 2 into secant power 4x derivative is 2 into differentiation of secant power 4x is 4 into secant cube x. Here 4 into 2 is 8 into secant cube x into, also we have to find secant x differentiation, that is secant x into tan x, plus 4 is constant, take as it is, into, here we have to apply product rule for secant square x and tan square x. Consider secant square as first function, tan square x as second function. That is secant square x into differentiation of tan square x is 2 into tan x into, again we have to differentiate tan x, that is differentiation of tan x is secant square x plus second function, that is tan square x into differentiation of secant square x is 2 into secant x into differentiation of secant x is secant x into tan x. You have to differentiate carefully. This is our f fourth derivative of x value. After finding f dash, f double dash, f triple dash and f power fourth derivative of x, we have to find these values at x is equal to 0. At x is equal to 0, f of 0 becomes, in the place of x you have to substitute as 0, that is tan 0 is 0. F dash of x is equal to secant square 0 is, secant square 0 is nothing but 1. Secant 0 value is 1, hence we get secant square 0 value as also 1. F double dash of 0 is 2 into secant square 0 into tan 0. Tan 0 is 0, hence we get f double dash of 0 value as 0. F triple dash of 0 is 2 into secant power 4 of 0 plus 4 into secant square 0 into tan square 0. This equation becomes 0. Here 2 into secant power 4 0 is 1, hence we get the value of f triple dash of 0 as 2. Similarly, f power fourth derivative of x. Here we have tan x term, here also tan x term, here also tan x term. Hence we know that tan 0 is 0. Hence we get f power fourth derivative at 0 value as 0 itself. After finding all these values, we have to substitute in Maclaurin series of expansion. Here f of x is nothing but tan x, which is equal to f of 0 is 0 plus x by 1 factorial into f dash of 0 values. Here f dash of 0 value is 1 plus x square by 2 factorial into f double dash of 0 value is 0 plus x cube by 3 factorial into f triple dash of 0 value is 2 plus x power 4 by 4 factorial into f power 4th derivative at 0 as value is 0. Plus and so on, we have to stop here itself. Simplify further, we get tan x value as x by 1 factorial is x itself plus here this value is 0 plus here 3 factorial is nothing but 3 into 2. Here 2 gets cancelled. Hence we get x cube by 3 plus. Here this value is also 0 plus and so on. This is a Maclaurin's expansion of tan x. This completes the problem. We have another problem. Using Maclaurin series, expand log of secant x up to the terms x power 4. Here procedure will be same as before. Consider the given function f of x is equal to log of secant x. To find f dash of x, differentiate this value with respect to x. We get f dash of x, which is equal to, here differentiation of log of secant x. This is of the form log x. Log x differentiation is 1 by x. Hence we get 1 by secant x into, again we have to differentiate this secant x, that is secant x into tan x. Here secant x get cancelled. Hence we get f dash of x value as tan x. Again differentiate f dash of x, we get f double dash of x, which is equal to, here differentiation of tan x is secant square x. F triple dash of x, which is equal to, here differentiation of secant square x is 2 into secant x into, again we have to differentiate secant x, that means secant x into tan x, that becomes 2 into secant square x into tan x. This is our f triple dash of x value. Now to find f fourth derivative of x, to make the simplification easy, let us write in the place of secant square x as 1 plus tan square x, that is 2 into, in secant square x is nothing but 1 plus tan square x. We know that from trigonometric identity, secant square x can be written as 1 plus tan square x into tan x. That becomes, multiply tan x inside the bracket, we get 2 into 1 into tan x is tan x plus tan square x into tan x is tan cube x. This is our f triple dash of x. Now we can easily find f power fourth derivative of x as 2 is constant, take as it is, into differentiation of tan x is secant square x plus differentiation of tan cube x is this of the form x power n, that is n into x power n minus 1, that is 3 into tan square x into, again we have to differentiate tan x with respect to x, we get differentiation of tan x is secant square x. This is our f power fourth derivative of x. After finding all these values, we have to find the values at x is equal to 0. For that, f of 0 is, substituting x as 0, we get f of 0 is log of secant 0. We know that secant 0 is 1, hence we get log 1 value as 0. Next, f dash of 0 is equal to, here f dash of 0 in the place of x we have to substitute as 0, that is tan 0 value is 0. F double dash of 0 is, here secant square 0, we know that secant 0 is 1, hence we get secant square 0 also value as also 1. That is our f double dash of 0. F triple dash of 0 is, here 2 into tan 0 is 0 plus tan cube 0 is 0. Hence we get f triple dash of 0 value as 0 itself. F power fourth derivative of 0, that is substituting x value as 0, here we get 2 into secant square 0 plus 3 into tan square 0 into secant square 0. That value becomes, here tan 0 is 0. Hence we get secant square 0 value is 1. Hence we get 2 into 1 is 2 itself. That is our f power fourth derivative at x is equal to 0 value. After finding all these values, we know that Maclaurin series of expansion is given by the formula this. Substituting all the value, here we get f of x is log of secant x, which is equal to f of 0 value is 0 plus x by 1 factorial into f dash of 0 value is 0 plus x square by 2 factorial into f double dash of 0 value is 1 plus x cube by 3 factorial into f triple dash of 0 value is 0 plus x power 4 by 4 factorial into f power fourth derivative at x equal to 0 value is 2. Plus and so on, we have to stop here itself. On simplifying the term, we get log of secant x, which is equal to, here 0 plus x by 1 factorial into 0 is 0 itself plus, here x square by 2 factorial into 1, here 2 factorial is nothing but 2 itself, hence we get x square by 2 plus, here this value is 0 plus x power 4 by 4 factorial into 2, here 4 factorial can be written as 4 into 3 into 2 into 1, here 2 gets cancelled, 4 into 3 is 12, hence we get x power 4 by 12 plus and so on. This is a Maclaurin's expansion of log of secant x. This completes the problem. We shall move on to another problem. Using Maclaurin series, expand log of 1 plus cos x to the terms x power 4. Take the given function as f of x, which is equal to log of 1 plus cos x. Here to find f dash of x, differentiate f of x with respect to x. We get f dash of x, which is equal to, here differentiation of log of 1 plus cos x is 1 by 1 plus cos x into, again we have to differentiate 1 plus cos x, that is differentiation of 1 is 0 plus differentiation of cos x is minus sin x. This is our f dash of x. To make simplification easy, let us write in the place of sin x as 2 into sin x by 2 cos x by 2. This is a half angle formula. We already discussed the half angle formula in previous videos. Sin x half angle formula is 2 sin x by 2 into cos x by 2 divided by 1 plus cos x half angle formula is given by 2 into cos square x by 2. Here 2 gets cancelled and cos x by 2 gets cancelled. We get sin x by 2 by cos x by 2 is tan x by 2, that is minus tan x by 2. This is our f dash of x. Next we have to find f double dash of x, which is equal to, here differentiation of tan x by 2 is secant square x by 2, that is minus secant square x by 2 into, again we have to differentiate this x by 2 term, that is differentiation of x by 2 is 1 by 2. 1 by 2 into differentiation of x is 1, hence we get 1 by 2. This is our f double dash of x value. Similarly, f triple dash of x is, here minus into 1 by 2 constant take as it is into differentiation of secant square x by 2 is 2 into secant x by 2 into, again we have to differentiate secant x by 2, that is secant x by 2 into tan x by 2 into, again we have to differentiate this x by 2 term also, hence we get x by 2 term differentiation is 1 by 2, that is 1 by 2 into 1 by 2 is 1 by 4. This is our f triple dash of x. Here 2 ones are 2 twos are gets cancelled, the remaining is minus secant x by 2 into secant x by 2 is secant square x by 2 into tan x by 2. This is our f triple dash of x. Next we have to find f per fourth derivative of x, that is minus 1 by 2 take as it is in outside the bracket into, here secant square x by 2 and tan x by 2 both are function. We have to apply product rule for this. Here secant square x by 2 into differentiation of tan x by 2 is secant square x by 2 into, again we have to differentiate x by 2, that is 1 by 2, plus second function, that is tan x by 2 into differentiation of secant square x by 2 is nothing but, here same as this, 2 into secant x by 2 into secant x by 2 into tan x by 2, hence that is tan x by 2 is tan square x by 2 into secant square x by 2 into, again we have to multiply x by 2, that is 1 by 2. This is our f per fourth derivative of x value. After finding all this, we have to find these values at x is equal to 0, that is at x equal to 0 f of 0 is log of 1 plus cos 0 is, cos 0 value is 1, hence we get log of 1 plus 1, that is log 2. F dash of 0, which is equal to, here minus tan of, here in the place of x we have to substitute as 0, that is tan 0 value is 0 itself, that is our f dash of 0. F double dash of 0 value is 1 by 2, that is minus 1 by 2 into, here secant square in the place of x is 0, that is secant square 0 is 1, hence we get minus 1 by 2 is our f double dash of 0. F triple dash of 0 is, here minus 1 by 2 constant as it is into, in the place of, here tan 0 is 0, hence we get all the values are 0, hence we get f triple dash of 0 value as 0. Similarly, f per fourth derivative at x equal to 0 is, here minus 1 by 2 into, here this is secant square x by 2, that is values secant square 0 is 1 into secant square 0 is 1, hence we get 1 into 1 by 2. 1 by 2 multiply with minus 1 by 2, that we get minus 1 by 4 plus this value becomes 0, hence we get minus 1 by 4 is our f per fourth derivative at x equal to 0. After obtaining all these values, we have to substitute in the Maclaurin series of expansion, that is log of 1 plus cos x. F of x value is log of 1 plus cos x, which is equal to f of 0 plus x by 1 factorial into f dash of 0 value is 0 plus x square by 2 factorial into f double dash of 0 value is minus 1 by 2 plus f cube by 3 factorial into f triple dash of 0 value is 0 plus x power 4 by 4 factorial into f power 4 derivative at x equal to 0 value is minus 1 by 4 plus and so on. This is our log of 1 plus cos x value. Here in the place of f of 0, we know that f of 0 value is log 2, hence substituting all the values we get the Maclaurin's expansion value as log of 1 plus cos x, which is equal to, here f of 0 value is log 2, here the x by 1 factorial into 0, this value becomes 0 plus into minus is 1 by 2, that is 1 by 2 into x square by 2 factorial, here 2 factorial is 2 itself, hence we get x square by 4, that this value becomes 0 plus into minus, here 4 factorial is 24, 24 into 4 is 96 plus and so on. This is a Maclaurin's expansion of log of 1 plus cos x. This completes the problem. Here we have another problem. Using Maclaurin series, prove that root of 1 plus sin 2x, which is equal to 1 plus x minus x square by 2 minus x cube by 6 plus x power 4 by 24 plus and so on. Here we have to prove that for the function root of 1 plus sine 2x, the value is obtained as 1 plus x minus x square by 2 minus x cube by 6 plus x power 4 by 24 plus and so on. Consider the given function, that is f of x is equal to root of 1 plus sine 2x. To make the simplification easy, let us write 1 plus sine 2x as sine square x plus cos square x plus 2 into sin x cos x. This is obtained by, here in the place of 1 we can write it as sin square x plus cos square x. From trigonometric identity we can write sin square x plus cos square x value as 1 plus sin 2x. Double angle formula of sin 2x is 2 into sin x into cos x. We can write as this. Here sin square x plus cos square x plus 2 into sin x cos x, this is of the form a square plus b square plus 2ab. We know that this formula is a plus b whole square. Hence we can write sin x plus cos x whole square. Here square and root gets cancelled in the next step. Hence we get f of x value as sin x plus cos x. Now we can differentiate easily, that is f dash of x which is equal to, here differentiation of sin x is cos x plus differentiation of cos x is minus sin x. Hence we get minus sin x. This is our f dash of x. F double dash of x value as cos x differentiation is minus sin x minus differentiation of sin x is cos x. This is f double dash of x. F triple dash of x is minus differentiation of sin x is cos x. Hence we get minus cos x minus differentiation of cos x is minus sin x. Hence we get minus into minus plus sin x. Similarly, f power fourth derivative of x is minus cos x differentiation is minus sin x. Hence we get minus into minus plus sin x plus differentiation of sin x is cos x. After finding all these values, we have to find these values at x is equal to 0. At x equal to 0, f of 0 becomes, here square root of 1 plus sin 2 into 0 is 0. Hence we get sin 0 value as 0. Hence we get root 1 value is 1. This is our f of 0. Similarly, f dash of 0 is cos 0 minus sin 0. We know that cos 0 value is 1 minus sin 0 is 0. Hence we get 1. F double dash of 0 is, here we have f double dash of 0 is minus sin this value is 0 minus cos 0 is 1. Hence we get minus of 1. Minus 1 is the f double dash of 0 value. Similarly, f triple dash of 0 is minus cos 0 plus sin 0. Here sin 0 is 0. Here we get minus cos 0 value is 1. Hence we get this value is also minus 1. Similarly, f power fourth derivative at x equal to 0 is sin 0 is 0 plus cos 0 is 1. Hence we get f power fourth derivative at 0 is 1. Substituting all these values in Maclaurin series of expansion, we get f of x value is root of 1 plus sin 2x, which is equal to, here f of 0 is 1 plus x by 1 factorial into f dash of 0 value is 1 plus x square by 2 factorial into f double dash of 0 value is minus 1 plus x cube by 3 factorial into f triple dash of 0 value is minus 1 plus x power 4 by 4 factorial into f power fourth derivative at x equal to 0 is 1 plus and so on. On simplifying, we get root of 1 plus sin 2x value as 1 plus, here x by 1 factorial is x itself, minus, here plus into minus x square by 2 factorial is 2, plus into minus x cube by 3 factorial is 6, plus x power 4 by 24 plus and so on. This is a Maclaurin's expansion for root of 1 plus sin 2x. This completes the problem. These are all some of the important question paper problems on Maclaurin series of expansion. In next video, we study about indeterminate forms. If you have any doubts regarding my videos, comment below. Hope you all like the video.